Hello and welcome. So, we have ourselves a circle here, and we're given certain lengths inside the circle, and we're told to solve for x. Whew! So let's figure out how what we have relates to each other first, and we'll go from there. So first thing that I notice is we have ourselves a right angle. Okay, and this is a property of circles that whenever you have something from the center of the circle intersecting a chord, and a chord just means a line within a circle, right? Connecting two points of the circle together in a line. That is a chord. Okay, and whenever you have a point at a right angle with an intersection with something else from the center is going to be a midpoint. So that is a midpoint of the line. And a midpoint means that whatever that distance is from K to T is going to be the same distance from T to B. So we're told that that's 8.5. We automatically know that that is also 8.5 on the other side. Huzzah! Okay, so that's some important information. We're also given this 10 over here. Now 10 is really special because that is a radius. Okay, anything that goes from the center of the circle to the circumference, that is a radius of the circle. That means that anywhere you draw a line, anywhere, from the center to the circumference, that's a distance of 10. And why that matters is that what if we drew a line from the center to K? Isn't that also a radius? Yeah, which means that's also 10. Booyah, right? And the reason why we want to do that is that what did that just form? Right triangle. And what do we always know about lengths and right triangles? The Pythagorean theorem. Wow! Right? Remember, Pythagorean theorem says that for any right triangle with legs A and B with hypotenuse C, you can take your leg squared plus your leg squared to equal your hypotenuse squared. Booyah, right? And this is a relationship you always have. Now, the reason why we want to use Pythagorean theorem here is look at where your x is. It's right there, right? It's that distance right there. So let me take out some of these highlighters, make it a little easier to see, right? Would you agree that from the center to the outside of the circle is a radius? That means that it's going to be the same distance. That's going to be 10. That means x plus, I don't know, I'm going to call that b, right? Whoa, that was crazy. Kind of jumped on me there. So x plus b equals 10, because that is a radius. So the reason why we want to use Pythagorean theorem is that if we use this length and that length, we can solve for this one right here. And we know that that length plus our little x here has got to be 10 because that is a radius that goes from the center to the outside of the circle. Okay, so let's solve for it. So I just accidentally took out part of our radius right there. Bam. Okay. So we take our leg squared. So we have an 8.5 squared plus our other leg, what we're trying to solve for, squared, equals our hypotenuse 10 squared. And then this is just a matter of getting those numbers down. So 8.5 squared means that you have 8.5 times 8.5, which is 72.25. Okay, and then from there, you have plus b squared equals 10 squared, which is 100. And you're solving for b squared. Remember, right? You want to get that alone. So if you have a 72.25 on one side, subtract it, move it over to the other. Oh, dropped it. 0 right there. There we go. So now we have 100 subtract our 72.25, which is 20, golly. No, I know this. It's 26. No, 27. Haha, 27.75. I do not know why that was a struggle. It was a struggle. This is fine. So b squared equals 27.75. Okay, and then from there, then that's just a matter of solving for your b squared, right? We want to get b alone. The square is stopping that, so we undo the square with a square root. Now remember, whenever you take a square root, you have a plus or minus, right? Don't forget about them. A little pesky to remember. But the good news is that if you did forget it, it's actually okay in this problem because we're not going to need the minus at all. Because think about it, you're looking for a length. Can lengths ever be negative? No, right? So we're only using the positive square root anyways. And that means b is the square root of 27.75. And we know that if we take that number, whatever this number is, and we add it to our x, we should end up with 10. So if we want to solve for x, right? Take the b over to the other side, and 10 minus our number, our value for b, which is the square root of 27.75, we should end up with our x. Shibuya! So, this is a time where I return right to my calculator, and I'd say, right, calculator, help me, right? 10 minus the square root of 27.75. Alright, calculator returns the number back, and it says 4.73217, so on and so forth. Okay, now for these problems, you're going to be rounding to the third decimal place. Alright, third decimal place, that third digit right there, so you'd have 4.732. The 1 behind the 2 is going to round down, which means 4.732 is your final for this one. So 4.732. Bam. And there you have it. You are finished from that point on. There's nothing more that you can do there. Okay? Thanks for watching.